Hello and welcome to our first video lecture on machine learning. This video lecture has two parts. In the first part, I will briefly introduce you to the field of machine learning. Most importantly, I will give you an overview of what it takes to build a model using a machine learning algorithm from a practical standpoint. So that's the first part of this video lecture. In the second part of this video lecture, we'll take a look at a very simple example involving a popular machine learning package in R called Carrot. I'll just show you what are the main steps you need to go through to create and pre-process a data set, train your model, and then use your trained model for making actual predictions based on a new data set or new data. So this is part two of this video lecture. So what is machine learning? As you probably well know at this stage of your academic or professional career, machine learning is a subfield of artificial intelligence. Again, as you well know, artificial intelligence is a very hot topic nowadays. Everybody's talking about it, even outside of the computing field. Some people are concerned, for example, that artificial intelligence will create profound socioeconomic changes across the globe. For example, by automating some of the creative tasks and jobs that were previously thought to be immune to automation. One case in point is the project that was initiated by Google. I'm talking about Google self-driving cars. I think now this project branched out into a separate company that is under the umbrella of Alphabet Incorporated, which is the holding company of Google. So now I think it's called something like Waymo Vehicle Project. So, this project involves using sensors and machine learning algorithms to train actual vehicles like Toyota Prius, how to navigate across congested roads of San Francisco Bay Area and other parts of the United States. I think since the time the project was initiated, it moved to either Phoenix or Las Vegas, something like that. But it was initiated in San Francisco Bay Area. So I found it amazing that those cars can navigate without a driver, just using their software and sensors, because San Francisco Bay Area is kind of congested. And also the landscape there is a bit hard to navigate. They have a lot of shorelines, mountains, hills, valleys, and things like that. So I was quite impressed with the initial results of this project. So this is just one example. So if you're thinking about driving a cab, as a plan B or as a main profession, then this is something to worry about, because it could be that given all those developments in artificial intelligence, there will be no need for human cab drivers within the next 5 to 10 years. So again, this is just one example. There are so many other applications of artificial intelligence. One subfield of artificial intelligence that I find particularly exciting from a practical and philosophical point of view is creative intelligence. Scientists, computer programmers, they create algorithms and software that actually produce creative work, such as writing music. I find it quite amazing because creative activities, creative tasks were thought to be like the last frontier where humans can have a stronghold against computers. But now we increasingly see examples where computers beat humans in those creative tasks. So that's something to think about, and I guess it all boils down to the so-called singularity hypothesis. This hypothesis has been discussed by many people, and the way I understand this hypothesis is that we are about to reach a point where artificial intelligence will set on a development path of its own, where we cannot contain it, to the point where artificial intelligence becomes smarter and more powerful than humans. So I'm talking about something along the lines of the scenario depicted in the Terminator movies, right? When robots, actually start fighting against humans. So some people are saying that we're already past that point. Some people are saying that we're about to hit the singularity point, after which there will be no return. But all camps, they seem to argue that there's a need to understand artificial intelligence better and develop certain laws and governance mechanisms that would contain artificial intelligence in a sense that prevent all those robotics and software applications based on artificial intelligence from doing harm to humans. And on the positive side, put artificial intelligence on a development path that will actually bring benefits to human civilization. So that's what's happening nowadays with artificial intelligence. You probably know more than I do because maybe you're following a particular subfield of artificial intelligence to a great extent. Machine learning algorithms, they are a big part of artificial intelligence. The essence of machine learning algorithm is that those algorithms, they analyze data, okay, and then they infer mathematical models based on that data. So they learn from data, right? So machines or computers, they learn from data by creating a formula that formalizes the machine's understanding of that data. And then this formula is used for making decisions or selections, again, based on the data set that was used for deriving that formula, okay? Now, this last part of the definition, that mathematical models are inferred from the data, is very important because that's something that distinguishes artificial intelligence from human intelligence, right? It's machines who infer things, who learn things from data. It's not humans telling the machines what to do and how to do it. It's machines learning themselves what data shows and what can be learned from this data and what kind of decisions or selections can be made on this data. So that's why machine learning falls under the umbrella of artificial intelligence, because machine learning algorithms, as the name implies, are used by computers to learn and become intelligent on their own. Machine learning is a vast field. Again, everybody seems to be doing machine learning, something in relation to machine learning in all kinds of fields, from computer science to marketing and accounting. Everybody is developing or using machine learning tools for making predictions, for analyzing data, for making sense of data, for building intelligent agents and things like that. It's a vast field. There are many books written on the subject, obviously. There's one link that posted to Canvas as a part of this module. It just talks about various models used in Carrot package. So Carrot package alone, I mean, it's a vast tool. The link that I'm giving you in Canvas contains many chapters, a lot of discussion points. So it's more like a book, just devoted to one single package in R that goes into details as to how to pre-process data that can be used with this machine learning package Carrot. What kind of models can be applied? What are some parameters of those models? What are some nuances of using those models? How to use or develop your own model? So it's like a book on its own, right? So we're not going to talk about the theory behind machine learning. It's a vast topic, and it can hardly be covered in a small presentation like that. So. But the good thing for us is that from a practical standpoint, you don't need to understand the theory behind machine learning. You just, if you want to just be able to use those tools. So from a practical standpoint, this is what you need to do with any kind of machine learning, right? First of all, you train the model, the algorithm, on a set of data. And then once you train your model, once you train your machine learning algorithm, you use this trained machine learning algorithm for predicting or making decisions based on the inferred mathematical model, based on what was learned. So train and then use that train model for predicting things. 2 steps. There are so many applications of machine learning. One of the early applications of machine learning is spam filtering, trying to look at emails and predict based on certain common characteristics. Most likely those characteristics are related to the wording itself, like what's inside that email. So machine learning was used for a long time to classify email messages into spam versus non-spam. Up to now, spam filtering is a big, important functionality of any kind of mailing service, including Gmail. And you know that it works quite well, but sometimes it would put a valid and important message into a spam folder. I'm sure everyone has experienced that. So machines are not perfect, at least at this stage of their development. However, what's scary is that in many ways they're better, they're more perfect than humans. Computer vision is another application of machine learning where images are recognized or classified by a trained model. For example, classifying portraits into male versus female, or let's say looking at security camera footage and classifying images or screenshots into suspicious versus non-suspicious, meaning images that may contain a potential crime in progress versus images that do not contain a potential crime in progress. So all kinds of applications are out there. Now in this example that we will take a look at now, what we are doing, we're classifying text messages into the ones related to eating and non-eating. Okay, so I'll tell you more what exactly we're doing and what exactly those messages are. Now to run this example, you need to have several packages installed. The two main packages that we're using here is caret and TM. TM stands for text mining. We talked about this package in quite a bit of detail in our previous lecture. And then, also this caret package also makes use of ARM and E1071, which is another machine learning. I believe it's, this particular package contains machine learning algorithm related to neural networks, because I remember using it in the past. So those are the four packages that you need. What I suggest, pause this video right now to make sure you have all those packages installed. Please use the install packages command to install everything. And then once you install everything, then use library command to activate or load all these four packages into the memory. So pause the video and make sure these four packages are installed on your machine. So once you have these packages installed and activated, this is what needs to be done. First of all, you load your data into a corpus. Your data is very simple. It contains only two texts or two messages. You can think of it as like two documents or two tweets, social media messages that you're planning to analyze. So basically it's a vector containing only two values, two strings. The first string says cats like to chase mice. The second string or the second message says dogs like to eat big bones. So the second message is about eating, while the first message is not about eating, it's about something else. Although it's somehow related to eating, it's more about behavior rather than food consumption. And both messages or both texts or documents, let's call them documents because that's the more common terminology in text mining. So both documents that are about animals, actually. So before we analyze these two messages, we will load them into a corpus. Now corpus, again, is something that we discussed in our previous lecture. It's a widely used term in text mining. A corpus is a collection of documents. That's what it is, because typically text mining tasks involve many documents, for example, many articles or many social media posts. But in our case, corpus is quite simple. It contains only two documents. Now when you just run corpus here, it won't show you anything because it's something that is internal to the text mining message. Now what we will do from this corpus, we will convert it. By the way, here in the data environment, you'll see that it's a list. So the data type is list. Now what we will do next, we will convert this corpus containing two documents into a document term matrix. I think it's actually I forgot, it's term document or document term matrix. I think term document matrix, TDM. That's a more common name. But nevertheless, so actually it's DTM, document term matrix. That's the order of words. So document term matrix is a function from the text mining package. It's a function that converts a corpus into a document term matrix. What is a document term matrix? It's basically your corpus, meaning your text. It can be comprised of one, two, many documents. It means that your text is aggregated across many documents, and specifically the way it's aggregated is as follows. First of all, you clean text, you remove punctuation, you remove stop words such as to, the, so to is a stop word here. You also do stemming, which means that you only keep stems of words as opposed to various variations with suffixes. And then you remove numbers, because this exercise is about text mining. It's about words rather than numbers. So you clean, and then what happens? You create a matrix, a table that lists common terms across all documents. For example, one term that's across two documents is like, it's a word. So basically you can think of a term document matrix as a table where each column is devoted to a particular term. So let's say it's like, and then for each document you'll have 0, 1. 0 means this term is not in the document. 1 means it's in the document. So in our case, for like, we'll have 1, 1 for document 1, which is this message, and for document 2, which is this message. For the term chase, that will be another column. We'll have 1 for the first document, which is cats like to chase mice, because it's mentioned, this term is present there, but it will have 0 in the second document, because in the second document we don't have this term chase. So that's what we're doing when we're creating a term document matrix. Sorry, it's document term matrix. Always reverse the order of those words, the first 2 words. So we'll create this document term matrix right here. So it has we have 2 documents once again. And then what we will do from this term document matrix, we'll create a training set. So the full set will be a training set. In more real world example, what happens is that for a training set, you take a subset of the overall data. So let's say you have millions and millions of records, and you train your model using, let's say, 1,000 records. And then once you train your model, you let your model make predictions based on the remaining 999,000 observations that you have in your data set. But in our case, we'll use the entire corpus as a training set. So once we create this document term matrix, we convert it, which is a list, by the way. We convert it into a matrix right here, and here you can see what's inside that matrix. This is what I was talking about. You have documents 1 and 2, and for each term you have a column. For example, term like is found in 2 documents. Cats like to chase mice and dogs like to eat bones. So that's why you have 1 and 1 against 2 documents. While chase is only found in the first document. Cats like to chase mice. So that's why you have 1 for document 1 and 0 for document 2. Okay. Now what we will do, we will add an additional column, which is a vector containing 2 values, 0 and 1. Okay. So we'll use cbind command to bind this vector and this matrix by columns. And then what we will do, we'll change the name of that added column that contains 0 and 1 to y. Okay. So now when you run train, you'll see that there's column y added. Now, what does this column y represent? Well, that's our classification variable. In other words, we're interested in classifying our messages into the ones that are about eating and the ones that are not about eating. So the reason we have 0 here is that the first document, cats like to chase mice, is not about eating. The reason we have 1 for y against document 2 is that the second document, dogs like to eat big bones, is actually about eating. Okay, and then to be used in order for this matrix to be used as a part of the caret package, we convert it into a data frame, and then we also change variable y into a factor variable. Okay, so now we are done. So now we have our table. So what we will do, we'll create an object called fit. Okay, so fit is our train model. Okay, we'll use train command, and what we're gonna say that train to predict y, which is whether a message is about eating versus not eating, based on dot. Dot means based on all variables, based on all columns in the data frame that we have. So based on all those words. So data is train, and method that we're using is Bayesian GLM, or general linear model. Basically, it's a regression. It's something very similar to a logistics regression, where the dependent variable is binary. It can assume value 0, 1, meaning about eating versus not eating, or let's say 1 means student will pass course, 0 means student will fail course. And then all variables in our case are actually dummy variables, because they're also binary variables. So in regression models, you can use binary variables, meaning the ones that can assume values of 0 and 1. They're also called dummy variables. So basically what I'm saying, it's one of those models. Again, click on the link that I provided in Canvas about all, it contains like a very detailed description of the caret package, and it talks about all models that are incorporated into this package. Anything from neural networks and all the way up to genetic algorithms and all kinds of other models are incorporated. Actually, I think some of the earlier versions of Carrot package contained 7 models. Now I see that there are like at least twice as many models, maybe 24 models that are implemented that can be used for machine learning for training based on a particular data set. So that's what we'll do. We'll train our model, and that trained model will be contained in the fit object based on the data that we have in the trained data frame, and we'll train this model to predict y based on everything, based on all terms. And then once we train it, we use this fit object, which is a list. We use this fit object to predict itself, right? So basically we're saying, okay, predict based on what we learn, based on the learning contained in that fit object, but the data that you're using is the same data that was trained. In other words, is it gonna predict itself? Well, it should, right? So when we run it, it makes prediction. The first document is not about eating, the second document is about eating. So that's exactly what we had, and this prediction is perfect because it's the same data set, right? It's the same data set that we used for training. But now let's do something different. Let's say we have the following document, new document: bats eat bugs. Okay, so we do all those conversions. We load this document into a corpus, then we convert it into a document term matrix, and then we call it test. So that's what's inside our test, right? So broken down into terms. And then we will see whether we can make a correct prediction about this single document. So we're going to predict based on what we learned, based on that fit object, and the new data that will fit in will be called test. So what's your prediction, without using any algorithm? Is this message about eating or not? Well, it looks like it is about eating. So when we run this prediction, we get 1, which means this message is about eating. So the model correctly classified this new data set containing only one document as the one related to eating. So this was a very basic example of using a machine learning algorithm on a very, very small, simple data. In the next example, we'll look at something that is a bit more complex and a bit closer to real life. It is actually one of the projects. It's a project by one of the students who took this course, so it will have a bit more data and I guess a bit more complexity to the model that was built. So thank you for listening.